é para fora, então é no gogó.
Primeiro também aqui, vocês olhem mais um pouquinho.
Minha esposa falou. Eu vou ter que fazer uma correria na hora do almoço, não vou conseguir almoçar junto, mas vou tentar participar.
Quanto tempo a gente espera para o reitor? Espera mais um minuto. A gente começa.
Pode mudar, gente. Já está online? Tá, ele demora um pouquinho, porque ele vai... É o minuto. Então,
Ok.
já está indo. E vê se o áudio está saindo pelo seu celular.
Vou entrar lá.
Outra coisa não consegui, não. Aquela reunião que eu esperava matar em 20 minutos.
Não, eu ontem caí. Bom.
Oi, André. Gostou ontem?
Começamos?
O Marcos está indo. O Fernando disse que ele está confirmando.
Ele está respondendo. Qual o corte?
Avisa que é no Inova, Fernando. Avisa que é no Inova. Avisa que é na
Vai lá buscar
sala
ele.
do Inova. Ele está lá no Reinaldo.
The provost is coming. So this way is at the door. So we don't know which door, but
You just want us to hang out? What can we do? Do you just want us to?
yeah, don't worry. We stay here. We will make a brief introduction. Just greet people. That will. Tá bom. Did I introduce you to? And okay. Oh yes, you were right. Yes.
Seu amigo.
Não, é mulher.
Daqui a pouco eu passo.
Foi surpresa, ninguém esperava. Apareceu. Não era para ver.
Acho que é. Essa daqui.
Essas coisas. É, né, por bem.
A massa. Que horas que ela vai entrar, você sabe?
Maravilhoso.
Não sei se alguma coisa aqui
Passada aqui?
Esse rapaz
TI da foda.
Mais cadeiras. Deixa algumas cadeiras vazias aqui, né? Sei por quê. Tá dando muito.
Ali, tem povo que tá indo pro fundão? Realmente a gente puxa.
Tem cadeiras aqui. Então, só para alertar.
Deixa eu fazer uma questão de ordem. Então, só um minuto, por favor. Questão de ordem. Fundão não vale, porque é o seguinte, as mesas têm que ser preenchidas com 4 pessoas, pelo menos. Então, não adianta ficar numa mesa com 3, que nós vamos colocar mais alguém. Então, eu pediria para aqueles que estão no fundo se deslocassem, porque aqui tem vários lugares disponíveis, tá bom? Porque tem as dinâmicas e vão ser feitas em grupos de 4. Obrigado. Song, você senta. Alguém não está com esse Wi-Fi? Ali, sim. Chegou? Tudo bem? Tudo bom? Para começar, já tem uma agenda. O que a gente faz? Do menos para o mais, eu acho que é o prato padrão. Sempre assim, do menos para o mais. Do menos para o mais. Último a falar é você, Reinaldo. Roseli, eu começo, você fala, a Benche, diretoria e a USP. O que você acha? Pode ser? Pode ser? Bom, vamos começar, gente? Vamos lá.
Aí amanhã, né? Modo de teste.
Hoje só 10h15.
Foi só 10h15. Ela finaliza a parte dela. Ela vai estar assistindo pelo online também.
Pelo YouTube, já tá no YouTube.
Gente, ó,
Eu acho que tá no Zoom também. Só que eu não sei como é que ela acessa, como é que ela pode acessar o Zoom.
bom dia a todos.
Já tá aqui, já.
Alô? Vamos sentar, gente? Não, o microfone é para fora, então eu não quero sair gritando. Senão na internet o pessoal vai embora. Bom, gente, bom dia a todo mundo. É uma grande honra e satisfação ter todos vocês aqui. Nós estamos começando uma jornada
Então vai ser também.
que eu espero que seja assim, relevante, de impacto para cada um de vocês e para as respectivas instituições. Trouxemos 60 pessoas, tem o pessoal do programa que a gente financia junto com a CAPES e a Embaixada, que é um programa que começou lá em 19 e que é o programa de modernização do ensino da graduação. E aí eu só vou dar o contexto disso daqui para quem não sabe e depois vou passar a palavra para o Seabra. Cadê eu acho que o Ricardo também queria que o Ricardo... Cadê o Ricardo? Você também falar alguma coisa? Para vocês saberem aonde nós estamos. Bom, o programa de modernização de graduação da engenharia começou lá em 19, no contexto de uma mistura de DCN, de Movimento Empresarial pela Inovação, e chegamos a selecionamos 8 projetos que estão sendo financiados desde então e que promovem basicamente a mobilidade de professores e pós-graduandos, né, que são os assistentes do programa, entre Brasil e Estados Unidos, para poder promover essa atualização, vamos dizer assim, do ensino. No meio disso, a gente foi atropelado pela pandemia, né, que foi, enfim, terrível sobre inúmeros aspectos, e que acabou até adiando o final do programa de 1 ano, e temos... As pessoas das 8 instituições têm ido, temos aqui... Se o pessoal do PMG, se pudesse levantar a mão, agradeceria, só para vocês terem uma ideia aí de quem são os que são do PMG, tá? E que só recapitulando, Cimatec, o FRJ, UFSCar, Itajubá, me ajuda, URGS, PUC, USP, URGS, Unicinos e PUC Paraná. Esqueci alguém? Não, então tá bom. Bom, aqui a gente tem um bom pedaço, umas 20 pessoas, mais ou menos, que são da USP, né, por razões óbvias, e os outros 40 são entre o pessoal do PMG e pessoas que nós convidamos para participar desse programa, que sempre foi a intenção do programa, de disseminar essas experiências. Então, nós tínhamos inicialmente planejado uma missão para os Estados Unidos para fazer um programa de treinamento sobre IA na educação lá, mas achamos que fazia mais sentido trazer os especialistas, que depois eu vou apresentar, para poder mais pessoas se beneficiarem. Então, isso aqui está sendo transmitido pela internet, a gente vai disponibilizar isso para a maior quantidade de pessoas possíveis. Os professores, o Andrew Katz e a Dayun Kim, que vai participar online, ela ficou lá em Virgínia, junto com a Bailey e o Mitch, que vão ser os TAs, os Teaching Assistants, que vão ajudar nas dinâmicas, é que vão promover isso. Eles vêm da Virginia Tech, tanto o Andrew quanto a Day Young fizeram são engenheiros químicos e fizeram um doutorado em Engineering Education em Purdue, que talvez hoje seja a referência na área de Engineering Education nos Estados Unidos. Então, pessoal da melhor formação, da melhor qualidade, com experiência, que eu acho que a gente vai ter muito a aprender com eles. Então, isso só foi possível porque teve o Ricardo, da PUC do Paraná, que nos ajudou a organizar isso desde o começo, ele que trouxe os contatos, o Seabra, que é o coordenador do biênio, que é o cara que cuida dos 2 primeiros anos da Poli, que tem 870 ingressantes, né? E que vai também dar umas palavras para vocês. Então, eu quero aqui, de imediato, agradecer aos dois, ao Ricardo e ao Seabra, por botarem isso de pé, Rangel, que tem sido fundamental, que está carregando o piano, e o meu pessoal, claro, né? Evidentemente, né? Tainara, André, Alexandre, toda a equipe da Fulbright que toca esse programa. Então, certamente a gente vai conversar bastante nos próximos 2 dias e meio, mas eu desejo que todo mundo possa tirar o melhor proveito da participação dos nossos colegas da Virginia Tech, e a gente vai ter bastante oportunidade nos coffee breaks e nos trabalhos de grupo e nos almoços para interagir e compartilhar experiências e aprender muito com o outro, que é esse o nosso objetivo. Tá bom? Então, eu vou parar por aqui, vou passar para o Seabra, para ele dar as boas-vindas. Seabra.
Boas-vindas a todas, a todos. É um prazer receber todos vocês aqui. É uma grande alegria e eu acho que é um momento muito importante. Talvez é o primeiro momento que a gente tem, acredito eu, no Brasil, de realmente congregar pessoas que são da área de engenharia, que certamente estão muito atentas a toda a questão de IA, né, e poder promover um evento onde todos nós estamos juntos discutindo esse assunto, e mais do que uma palestra, é um workshop, né, com especialistas, como disse o professor Loureiro, né, muito experientes no assunto, que estão trabalhando muito com esse assunto e tem toda a base de engenharia para fazer isso. Então, acho que a gente tem que aproveitar isso ao máximo mesmo, né? Então, vai ser uma alegria muito grande, é uma alegria muito grande para a gente. Nós temos uma equipe de apoio também, que vocês têm qualquer dificuldade ao longo do processo, a tomada não está funcionando, eles vão estar dando suporte para vocês, para que tudo flua muito bem, tá bom? Então, basicamente é isso que eu gostaria de dizer e agradeço aí, passar aqui para o Ricardo, né, parceirão. Aliás, uma das coisas, só para comentar, que eu sempre reforço do PMG, eu acho que a grande questão que o PMG conseguiu criar foi o fato da gente colaborar muito, né? Tá, bom, as pessoas que eu mais assim tenho contato, a Tati, né? Que está lá no fundão, né, Tati? Está lá no fundo. O Ricardo, né? Tem um monte de gente aqui, nem vou começar a falar, porque senão eu vou começar a apontar dedo para todo mundo. Tá bom? Mas é uma grande alegria.
Ok, obrigado, Seabra. Obrigado, Loureiro, por me convidar para ajudar a organizar esse workshop, né? A história começou, na verdade, a PUC Paraná tem parceria de longa data já com a Virginia Tech para intercâmbio de estudantes, e daí nós ficamos sabendo que tinha o Departamento de Educação e Engenharia lá. Teve uma equipe que foi para lá em 2022, se não me engano, pelo PMG, né, com suporte da CAPES e da Fulbright. E daí, o ano passado, eu fui com um grupo de doutorandos para lá também, né, conhecemos o pessoal de Educação e Engenharia, a Diana Baraktarova, que foi no workshop da PUC no ano passado. E daí o Loureiro nos chamou para ver quem poderia falar sobre a IA generativa na Educação e Engenharia. Aí eu comecei a fazer meus contatos das viagens que eu tinha feito com os cursos de engenharia lá nos Estados Unidos, né? E daí a Jenny Casey, que é a chefe do Departamento de Educação e Engenharia, gentilmente indicou o Andrew e a Dayong para conduzir esse workshop, que originalmente seria lá em Washington, mas pelo conteúdo que foi proposto, o Loureiro decidiu trazer para o Brasil para poder impactar o maior número de professores aqui e a gente poder disseminar esse conhecimento por todo o país, ok? Obrigado aí pela presença de todos.
Bom dia a todas e todos. Eu sou professora titular aqui da Poli também, mas hoje, como o professor Luiz Loureiro falou, eu estou aqui representando a ABENGE, Associação Brasileira de Educação e Engenharia. Quem que esteve na semana passada no COBENGE? Então, já aproveito, nós tivemos o COBENGE, que é o nosso congresso anual, que foi na PUC Campinas, e no ano que vem ele vai ser em Minas Gerais, na PUC, lá em BH, na PUC Minas Gerais. Então, a gente convida todos vocês, né, que têm interesse no tema, senão vocês não estariam aqui, e eu vim aqui em nome da Benja cumprimentar o professor Loureiro, toda a equipe pela iniciativa, né, porque a gente precisa realmente engajar, né, as universidades e todas as outras entidades de ensino superior que trabalham com engenharia, porque o mundo está avançando muito rápido, né? Eu acho que algumas pessoas só se deram conta de quão rápido com o advento aí da IA generativa. Então, se a gente não se ajudar, a gente não vai conseguir, já que vai ser em Minas, né, de entrar nesse trem e acompanhar a evolução. Então, eu queria cumprimentar aqui a Escola Politécnica, a Universidade de São Paulo, e agradecer a todos pela presença.
Bom dia a todos e a todas, uma satisfação estar aqui abrindo aí o evento. Acho que todos aqui sabem da importância, né, de inteligência artificial como, enfim, uma onda que está passando agora, e nós temos que, enfim, aprender a usar adequadamente, né, essa ferramenta. Se nós não soubermos ensinar bem os nossos alunos a usar essa ferramenta, eles vão aprender a usar de uma maneira inadequada, né? Como qualquer coisa. Então, acho que é super importante estar fazendo esse tipo de evento para a gente divulgar melhor, discutir, conhecer as melhores técnicas, porque isso para a gente vai ser fundamental. Quer dizer, não dá para pensar que isso vai passar. Não, isso veio para ficar, então a gente tem que aprender como usar isso bem, né? Então, eu queria, na verdade, cumprimentar a Fulbright, todas as entidades que participam aí do programa, cumprimentar os nossos palestrantes, aí, cumprimentar também todos vocês por estarem interessados nesse assunto e estarem aqui discutindo para a gente fazer, enfim, uma melhor formação dos nossos profissionais. Tá? Obrigado.
Agora, para dar as boas-vindas em nome da universidade, professor Marcos Neira, pró-reitor de graduação.
Mas como é leve? É de mentirinha. É de mentirinha. Funciona. Bom dia, gente. Bom dia. Eu gostaria de cumprimentar todas as pessoas presentes, gostaria de cumprimentar os organizadores do evento e parabenizar os organizadores e as organizadoras pela iniciativa. Dizer para vocês que a Universidade de São Paulo está já há bastante tempo preocupada com o que os traz aqui, que é como a gente melhora aquilo que a gente oferece para a população, e um dos nossos principais serviços é justamente o ensino. E nós temos insistido nessa questão, nesta gestão, que agora se aproxima do final, com a criação de um programa específico para tratar desse assunto, o Programa de Desenvolvimento Profissional Docente. E eu gostaria de mencionar essa iniciativa, porque todas as atividades envolvendo inteligência artificial são as mais concorridas, as mais disputadas. E isso alcança não só os professores e professoras das nossas 5 escolas de engenharia, mas os professores da universidade como um todo. Então, nós estamos diante de um contexto bastante singular de transformação do público discente. Acho que todos nós identificamos isso em todos os cursos, não é diferente também nas engenharias. Temos uma transformação do conhecimento, porque, afinal de contas, nunca tanto se produziu em busca de respostas aos dilemas da sociedade, e temos também uma transformação das ferramentas. E acho que a maioria já se deu conta que precisamos correr atrás desse processo sob o risco de ver o bonde da história passar, não é uma palavra muito adequada para engenheiros e engenheiras, suponho, né? O bonde da história passar e nós ficarmos correndo atrás, né? Então, historicamente, o currículo sempre foi algo que tenta buscar respostas para aquilo que está na frente. Então, a sociedade vai se transformando e nós vamos produzindo conhecimento tentando, né, responder aquilo que já está adiante. E desta vez, acho que as escolas de engenharia, de uma maneira geral, este grupo, de uma maneira bem pontual, apresentam-se para a sociedade como exemplos na busca de respostas ao mesmo tempo em que o fenômeno está acontecendo. E seria muito importante, na medida do possível, falo para os organizadores, que nós pudéssemos também dar publicidade aos conhecimentos e às experiências que aqui forem produzidos para que outros cursos, outros professores e professoras também se beneficiem. Então, parabéns à realização do evento, parabéns à Escola Politécnica e às demais escolas de engenharia, e aos visitantes, sejam bem-vindos e bem-vindas também. É um prazer recebê-los aqui na Universidade de São Paulo para esses dias de trabalho. Muito obrigado.
Obrigado, professor. Bom, pessoal, eu acho que com isso a gente encerrou as introduções, demos as boas-vindas, expliquei o contexto, e agora mãos à obra. Então, para isso, quem vai tocar, bom, de novo, né, dentro das metáforas, o barco agora, já que passou pelo bonde, pelo trem, né? É o Andrew, né, a Bailey e o Mitch, e da Jung à distância, que vão nos conduzir, né, ao longo desses dois dias e meio. Vamos ter um momento onde vamos ter pessoas de fora, que vai ser bastante interessante, que vai ser essa manhã, né, que vai ter elementos da indústria, de empresas de consultoria, que vão também dar os seus inputs sobre a questão. Então, agora nós vamos virar a chavinha para o inglês, certo? Então, without any further ado, I pass the floor to Andrew, and I'm very happy to have you here. Thank you for coming. Thank you, Bailey. Thank you, Mitch. So I wish you a wonderful and successful 2 days and a half. Okay.
Thank you. Thank you.
Awesome. All right.
Thinking. All right. Excellent.
Okay. Because we are sitting here and there, so that's the reason why.
Is that gonna work? Yeah.
Okay.
Does that work?
You can manipulate. Showing that on that TV.
Yeah.
We can, it's not fake, okay? You can grasp it here.
Oh, yeah.
See
Oh, look at
the-
this. Oh, wow. Technology.
Technology.
Yeah. Okay, good. Then I'll do introduction. I'll pass it over to Mitch. And then
Okay.
Mitch will get us started. He'll lead the
Oh,
first
okay.
module, but yeah. Oh, there's another one.
Yeah. It's okay. Cool, thank you. I don't know if it's better here or there, but that's okay.
Great.
Good.
Yeah. Great.
Right.
Feeling good?
I'll get into it. I don't really mind presenting. And I try not to get amped. I try to calm. All I can tell you is that the first, I don't know, 5 to 10 times I did this sort of thing, the heart was always really racing and then you just get used to it.
My mom's been saying that like since I started presenting in school, like 5 years ago. You're like in kindergarten, like show and tell. I couldn't do that. I was always like, so this is a penny I found on my way to school, you know? Good to do it.
I do a lot of breathing techniques, which I've learned from racing. Like before a race, you want to get amped, and then on the other side, you know, like a good one to do is you breathe in, hold it for 3, breathe out. Breathe in, hold for 3, breathe out. It's your parasympathetic nerve system. It helps you calm down and get control over your breathing. The other way to get amped up is the opposite, where you do very quick inhales followed by long exhales. Whatever. It brings your heart rate up really fast. So like right before a race, when I'm about to start, I'll just be like doing really breathing like that, and it just shoots your heart rate up. But then like then you're ready.
The microphone.
So maybe that's for the back, right?
The
Another one.
Will the microphone pick up for the back, or is it more?
No,
That's
just for
that.
the streaming.
I think today I really stuff off and randomly it's just I've got two sides that I'm having. It's like.
Well, you can say hi. You can introduce yourself.
Just so you all know, this is more for the online, for the audio for the computer, not
Oh,
for
okay.
like the room. So I thought originally like, oh, it's a microphone for the room. It's not that.
Okay.
So you'll just want to project.
Yep. Thanks for the heads up.
I did not realize that.
Just talk slow and use easy words.
Yeah.
It's one thing I've been noticing is like, okay, this presentation yesterday. Just make sure you're giving good.
All right.
pauses and
Good morning.
using like very large or complicated, like I said.
So
autism.
to start,
Do it.
thank you all for having us, for being here. For anyone who attended the lecture yesterday, and I'll do the same thing, which is to thank you all for letting us present in English. I speak Spanish. That's not going to help us much. Mitch speaks Latin. Also not going to help us much. Bailey, I'm not even sure. Barely English. So just thank you all for the next 2.5 days, while we're together. We'll be leading you all through 11 different modules. You'll have seen this in the itinerary. Each one of us will lead one of those modules. There'll be basically mixes of us going over some content, some ideas, but then also a lot of work time. So lots of activities to try and help you all think about how to maybe make changes or updates to your teaching, your courses, as it relates to integrating AI in some way, however that's appropriate for you in your context. So as you heard earlier, I'm Andrew. You've also seen my face everywhere. I apologize for that. And joining us, as you also heard earlier, I'll ask them to stand up briefly. So Mitch and Bailey. Yeah, so y'all go ahead and just stand up quickly to make sure everyone knows who you are. And then Mitch and Bailey are both graduate students in our program. So Mitch works with me at Virginia Tech, and Bailey works with Dayung at Virginia Tech. They can say more about themselves as they get started, but Mitch focuses a lot in the area of expertise development and how AI may be changing that expertise development in our students. And then Bailey focuses in the areas of workforce development and ethics education. And as I said, they'll be happy to tell you more about themselves. I'm sure we'll have lots of time for discussion during breaks. So please come talk to us, come talk to them. They'll be happy to talk to you. With that said, I'm going to hand it over immediately to Mitch, who will get us started. He'll go through this first module, and then Dayung will help lead, virtually the second module. We'll have our lunch, and then I'll be with you all this afternoon for the third and fourth modules. So that's the plan for today. I'm going to take this microphone off before I start making.
Morning. Really excited to be here. Thank you for having us. Thank you for hosting us. Thank you for attending. So this first module is going to talk about some foundational stuff. Basics about generative AI, basics about AI, machine learning, so that we can build from there and build our understanding. Also help give ourselves a little bit more information for our students. Talk to them about where these technologies came from and what actually they do under the hood. So this is a QR link to a Google Drive that we put up. They should have PDFs of all the different modules. I've also included, for the ones that I'm doing, some notes, some skeleton notes. So you can fill them in if you'd like.
Take your notebook, your preference. Yeah, so as I said, some learning objectives for this first module. We're going to recognize some different types of AI systems. Distinguish between AI, machine learning, deep learning, generative AI, because those are all different things, but they were thrown around quite a bit. We're going to look at the history of AI, how we got to where we are. We're going to look at some generative AI benchmarks, because those are used quite frequently in the industry to talk about the capabilities of different models. And we're going to talk about AI literacy, which is the idea that we can know AI, we can use it in our everyday lives, we can create things with AI, and also we can teach our students using this type of framework. And lastly, we're going to learn a little bit about ethically navigating how to use these tools, how we should and shouldn't be using them, and ideas about model alignment, which we'll talk about today. So as I said, AI literacy is kind of a hot word right now in the industry. It means a lot of different things, but broadly, it helps us get a better grasp of different aspects we might want our students to know about it. So recognize, we want to be able to see AI technologies in our everyday lives, recognize the times that we're using them and the times that we're not using them. Know and understand some aspects of how it actually works under the hood. Use and apply how you can use it in your everyday life, for your research, for your teaching. Evaluate, how can we be critical about these tools? Create, can we make some new stuff with AI? And ethically navigate, how do you navigate these things in an appropriate way? So this framework comes from actually our colleagues. This paper here from 2024, where they did a review of different AI literacy frameworks, and these were the big constructs that came up. So the module here is going to go through a few different ones. But I want to start, okay, cool. I want to start with some interactive stuff to make sure we can do this, because I have some interactive questions. So if you could go to the website, you can use your phone or the QR code. Ideally, it should pop up on the screen. What do you think of? Maybe one word or two words when you hear AI can replace doctors, teachers, lawyers, engineers. What does it make you think? Small? Too small? Okay. I can't zoom in. Okay, sorry. You can? Okay. Ah, joke. Cool, it works. Terrific. I'm glad this is working. Yeah, so we're already seeing a lot of skepticism, reductionism, replacement, anxiety, no way. So glad we have a little bit of criticality here. Renewing, suspicious, wrong. Yeah, so a lot of disbelief, not really thinking that these tools can do what all of us do. So let's dive in a little bit more. So about the history of AI. AI has been around for quite some time. The term artificial intelligence was actually coined for the first time in 1956 at a conference held at Dartmouth with a bunch of 20-year-old new researchers like myself, who wanted to put together a new field that was focused on mimicking here it is, every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. That was the initial motivation for creating this conference, was let's just make something that can do what humans can do. And it was a very, very ambitious goal. And in the 1950s to the 1970s, much of the work around AI involved rule-based systems. So you can think of these as if-then logic for anyone who's familiar with programming, state machines, really trying to capture the ways that we make decisions. But very quickly it became clear that these types of technologies were much harder to create than planned. And the original organizers all took very hardline stances about the types of technologies that they thought would create the ability to do human-like reasoning, human-like abilities. Some people thought that it would be in just creating more complex if-then statements. Other people thought that we would need a new type of understanding about common sense knowledge and world knowledge. And a lot of those ideas are still around today, and we still see many of the same motivations at large schools like Carnegie Mellon, at MIT, at Stanford. Many of these big name figures who came up in the early days of AI have had a huge, huge outweighed impact on the field's development as a whole. So that was in the 1950s to the 1970s. And it obviously AI has been around even before then, as I say up here. The idea of having little machines that could do what humans could do has been something that's always fascinated us as people. The Greeks would talk about having a little thing in your mind that made decisions for you. So the idea has been around for quite some time. But after the 1970s, all the hype that came out of this big grand goal started to bite them a little bit. And funding agencies decided, you know, you guys really aren't making that much progress on this big goal that you had. And funding dried up. And that's what is now known as the first AI winter. So that was in the 1970s to the 1980s. And it was very hard to make any progress at that time. But later in the 1980s, the 1990s, some of that early technology that was, some of that early technology that was in that first big wave started to be applied for actual applications. Predominantly actually in Japan. And we saw the rise of things that are now known as expert systems. So systems that aim to mimic the functions of experts. And it was actually quite difficult to make these systems. It required very long interviews with experts where you would draw out all this information that they might be thinking about and just essentially writing it into code. And a good example of that is a system called MyCin, M-Y-C-I-N. And MyCin was created to diagnose blood disorders. And they talked with tons of doctors and asked all these different questions about what made a certain symptom related to a certain disease. And MyCin was limited by the amount of space that they could put in computers at the time. But it was one of those first expert systems that grew in the 1980s and 1990s. And we also saw the rise in that time of machine learning. So machines that can learn from previous data, from previous operations. And this new success in machine learning and in expert systems that were applied to things like manufacturing or shipping costs, it led to a lot of new attention, a lot of new funding for AI. So again, we saw a really big surge in funding and projects and research in the 1980s and 1990s. We saw neural networks, which we'll talk about in a little bit, come into play. And again, new ideas about replicating human understanding, replicating humans, replacing humans, and all the stuff that we're hearing today happened again because all of a sudden we had new money and new ideas and new enthusiasm. But unfortunately, I bet you can guess, there was the second AI winter in the 1990s, and this again was driven by overestimations of AI capabilities. So people saying, oh, look at these expert systems. Next thing you know, we have a doctor, and the doctor never actually was produced. So the second winter was quite significant because at this point, there were many companies that were trying to create AI systems, and there's this first book found that over 300 AI companies shut down by the end of 1993. So that's quite a change in such a short span of time. And that really continued into the 2000s. But what the 2000s allowed in a new way was researchers to leverage big data, or these huge stores of information that were now being generated from the budding internet. People could take all that information, plug it into a new expert system or a machine learning application, and voila, you get some cool patterns that are very useful to us. So the 2000s to the 2010s, again, another big area of growth for AI, a lot of that driven by the availability of this data. The 2010s to 2017, an expansion of many of these ideas, and we saw really the creation of two big branches of AI research today, that which is called narrow AI and general AI. Narrow AI applications are those that are focused on specific applications. So an example of that I have on the board is Google's AlphaGo. Anyone heard of that? Yeah? Go is an old game played very popularly in China. It's a very complicated game. Far more complicated than chess. The number of moves that are available at any given point in time are astronomical, truly astronomical, literally. So it was always a goal for AI researchers to be able to create something that could play Go, because we, as humans, are the only thing that can play it, as far as until 2016, Google created the AlphaGo AI system, which was extremely good at just playing Go. So it's an example of narrow AI, because if you change anything about the board, or you try to take that system and then move it to like chess, it doesn't work anymore. And that's really the hallmark of narrow AI, is that it works extremely well under certain conditions, but then doesn't transfer well. That's not what humans do, right? We can transfer our learning very quickly between situations. We can learn these patterns very fast. Little children can learn this stuff and then quickly transfer between situations. Narrow AI and AI more broadly have a very challenging time at doing that type of transfer. The other type of AI is general AI, and this has been getting quite a lot of attention recently. I'm sure you all have heard about artificial general intelligence or artificial capable intelligence, ACI. And that's the idea that we could create an AI system that effectively would be able to do all the general capabilities that we humans are able to do. And that is still a goal for many of these big research companies, AI researchers, is this idea of a general type of AI that doesn't care about tax. Yeah, so then in 2017 was a huge moment. Google introduced the transformer architecture in a paper by Vaswani et al. Called "Attention is All You Need." And the transformer architecture exploits, and I'll talk about this in a little bit, a system called multi-headed attention. But basically what that does is it allows a natural language AI system, so a system that's learning how to understand human language, to focus on the important pieces of context in a large section of text. So when Google released this, it led to a huge, I mean, we're seeing it today, a huge boom in AI. Because the transformer architecture is actually something that you can put into other AI systems. So now we're seeing not only the advancement of transformer-based large language models, transformer-based natural language AI systems, but also transformer-based image systems and audio systems, and people using the similar idea into different applications. And that's led to this huge boom that we see in the 2020s to now, where there's a lot of AI investment. I know in the United States, it's over $400 billion of venture capital so far. And it is to be determined if we're going to see another AI winter, or if maybe this will be finally when all those initial ideas come to fruition. So this is a real key point, synthesizing all those ideas. What we call AI today is totally ambiguous. There is no, I should say, there's no such thing as an AI.
It is a very, very broad field that encompasses people who are computer scientists, cognitive scientists, neuroscientists, engineering ed people, all of you. It's a large area of study that encompasses a lot of different techniques, a lot of different systems, but ultimately it's interested in pattern recognition, prediction, and that's the underlying idea that drives many of these different systems. Yeah, so we're going to move now to the recognize part of the framework, which again is learning to see where these tools are in your everyday life. But first, there's a lot of terms. So why don't we get a little bit more clear about what they all mean? So as I said, AI doesn't really mean any one thing. And that's the overarching field, topic, whatever you want to call it, that is a whole set of different methods focused on creating computers that can do human-like functions. An example would be face recognition systems, autonomous vehicles, robotics, anyone who's used like Apple Music or Spotify, recommendation systems like that. Those are examples of just AI. Machine learning is a subset of AI that focuses on allowing machines to understand and improve, to learn from its previous outputs and from the data without being explicitly programmed to do that. So remember some of those early systems, that like Mycin, where you had to put all these different rules into it in order for it to work? Machine learning tries to avoid that by allowing a model to take many different passes at data and over time learn new information, learn new capabilities. Deep learning is a subset in AI and machine learning, and it generally focuses on using multi-layered artificial neural networks, which I'll explain in a bit, to find those patterns and make predictions. So it is a type of machine learning, it's trying to learn, and deep learning involves a specific type of architecture often that is used to do that type of function. Large language models are a type of deep learning system, a specific type of deep learning system, again, that uses neural networks to learn, process, and generate text. And that generate part is key for the next item, generative AI, which is the broad field of study and also broad range of different models that ultimately generate information based on what it has learned previously. So examples are not just ChatGPT, which can use text, but DALL-E for images, Midjourney for images, VO3 does video, 11 Labs is an audio system, and Cursor is for programmers. So a lot of these different systems leverage generative AI. So to give you a sense for all, I don't know what fields everyone comes from, so I thought I'd put together a lot of different possible ways that AI is being used in engineering. So I'll just be quiet for a sec, and maybe you can look. I have another slide too, so if your field isn't up here or something, hold on a second. But as you can see, there are tons of applications. And there are ones coming out every single day, it feels. So it's hard to keep up. But the point of having these different systems on here is just to show the AI is not something new that's popping into the world right now. These systems have been embedded for quite some time. And you've probably used them in your everyday life many, many times. You might have already used them on your way here if you used like Uber, right? Or you did Google Maps or something, or you actually flew here like we did. All of those different systems require AI routing and route optimization to be able to function. And we wouldn't be in the society that we are today without them. So here's some from healthcare, manufacturing, and energy. The next slide has some more from cybersecurity, graphic design, creative stuff, educational technologies, legal. My dad's an attorney, and he's dealing a lot with now all these new legal systems that are coming out that give people cases. Some are better than others, as is a theme in AI. But as you can see, a lot of different applications. So what are some cross-cutting themes here? The first are large language models that we talked about before. Many of these new AI systems and the growth of them across these different industries rely on some type of large language model for their functionality. Whether that is taking a user's input, doing some stuff, and then giving it to a model, and then doing something back, and then handing it off to you, or it's taking a large language model and that's really fine-tuning it for a specific application. Large language models are really supporting the boom in AI that we're seeing today. Computer vision is also a big theme in AI research. It's using models to, as it sounds, see images, recognize things, recognize faces, recognize stop signs. Has anyone done one of those Google CAPTCHAs where it says, which is a stop sign, or right, like which is a traffic light? What you're doing is giving data to Google so that they can train new models. So you are helping them become better. And actually what's kind of funny about that is, I don't know if anyone's noticed with those, but over time, they've gotten a little harder. The different problems that they give are now changing because the models are good at the tasks that we used to give them. So now they need to keep making it more challenging in order to improve them. So keep giving them your data. You're the product. Natural language processing, that is some of the techniques for text analysis that underpin large language models and other language processing systems. Predictive analytics, so this is using AI to make predictions, to do forecasting, obviously very common in things like financial markets. And robotics and automation, we're seeing this in manufacturing, we're seeing this with autonomous cars, all over the place. So these are some big themes in AI that have been around and are continuing today. Okay, so now we're gonna go, this is probably gonna be the most technical that we get, okay? So feel free to ask any questions. I'm gonna try to keep it extremely high level. But this is gonna talk a little bit about how some of these systems work, okay? So that picture is of a single neuron, and this is a paper that came out quite recently, 2024, where they mapped a 1 nanometer cube of the brain, all the neurons in a 1 nanometer cube. And I highly recommend looking at this paper because it's astounding to see just how complex the brain's connectivity is. So this is a single neuron, and in this single neuron, it's connected to 5,600 other neurons. And some neurons might be connected to as much as 10,000 other neurons, receiving signals at, I don't know how to say it in Portuguese, but at very, very, very fast rates. So your brain is constantly getting all these different signals from other neurons in different patterns and different activations. And the idea of a neuron drove the creation of what's called a perceptron. And this perceptron, this basic idea came from Frank Rosenblatt in 1958. So remember, the first conference was 1956. 1958 was the invention of the perceptron. The basic idea is to do something like we have in our brains, but a little bit simplified, where you take some different inputs and you pass it into a control unit that activates based on those different inputs. So if you have all of them coming together and it reaches a certain threshold, your output is 1. Simple as that. And it, again, extends from the idea of a neuron, where if other neurons are sending signals to one neuron and it reaches a certain potential, then that neuron fires. And the idea was to see if we could do something similar to that in a computer. So to see how that kind of works, here's a very simple example of a handwritten 8. And the numbers behind the 8 are it's just from black to white, where black would be 0 and white would be a value of 256. Doesn't really matter why. But the numbers behind all those different pixels just coordinate to what that pixel's numeric value is. We could then take each one of those pixels, go along the row and all the way down, right? And then we can map it to a single perceptron and train it over time to learn to activate when it sees an 8. And the way we do that is by correcting the different weights of the inputs based on the output that that perceptron puts out. So let's say we give it a number and it puts out a 0 and it turns out to be an 8. Well, then we use a technique called back propagation, where we take the output and go backwards in time and adjust the weights of all the different inputs so that it gets us closer to that desired output. So that's the basic idea of a single perceptron. And when we get to multi-layered, as I said before, multi-layered artificial neural networks, what we're doing is actually connecting many of them together. So instead of just having every single input go into a single perceptron, every single input goes into many different ones. And we might even create what's called a hidden layer. So you have different inputs go into this intermediate one, which is hidden to us. And then from those, it connects to all these different ones on the output. And ideally, it could then tell you if it's an 8, a 6, a 3, like that. So that's the basic idea behind a neural network. It gets more complicated from a math perspective, a computer science perspective, but at a fundamental level, that's what we're doing, is we're just connecting, like neurons, a bunch of these different perceptrons together, and we're telling them to activate based on the other neurons that are, the other perceptrons that are connected to it, and we're teaching them how to figure out these different weights based on our training data, and we're adjusting over time. Yeah. Good so far? Yeah? Okay, cool. Oh, we're gonna have to wait for the whole, there you go, I get to see it all again. Okay, so how now do we take that idea of a perceptron or of a multi-layered artificial neural network, and how do we create large language models? Well, the first big problem is that those types of neural networks need numeric inputs, and language is not numeric. So we could do something, a very simple strategy, where we just had a large vocabulary. Imagine the whole Portuguese or English language, and we just gave every single word a number. And we just said 1, 2, 3, 4, 5. We could do that, but it's a very simple approach. A more sophisticated one is the notion of embeddings. And the logic behind this is to group words that are commonly found together. Because if they're commonly found together, they're probably related. So embeddings allow us to take a word and translate it into what's called the meaning space, the embedding space, and that then creates a numeric input that we can use for these artificial neural networks. So I wanted to show, let's see. Ooh, where is my cursor? Yeah, okay. So this is a simplified, it's not a fully inclusive, so it's only 10,000 words, okay? But this is the word2vec embedding data set. And the word2vec embedding data set is used very commonly by large language models to, again, take language and create numeric inputs. So right now, it's projecting words into a three-dimensional space. But you have to keep in mind that when we're talking about these different models, we're actually talking about multi-dimensional spaces way beyond 3 dimensions. I'm pretty sure that the Quen model, which is a recent one that was created, uses something like 17,000 dimensions. So we're talking totally different orders of magnitude. But this is to give you a sense of what is actually happening. So what I'm going to do is put in the word engineer. And you can see, so it isolated engineer. Ooh. And it also told me some words that are commonly found with it. So we see scientists, engineers, engineering, designer, inventor, mathematician, architect, physicist, astronomer, chemist. Anyone want to see one? Call it out. Huh? Nothing? Okay, I'll do mathematician or just math. So here, mathematics, arithmetic, mathematical, elementary. So what this is showing us is, again, the co-occurrence, how frequently words are seen next to each other. And we use that as inputs into, maybe, we use that as inputs into a large language model. The next step, as I mentioned, the next step, as I mentioned before, are transformers. And yeah.
Sorry.
No,
for
absolutely,
interrupting.
yeah.
Are those clustering of words done by hand, or what were once done by hand and now they are more automatic?
That's a great question. The way that those are generated is actually from another neural network. So they created a specific type of neural network to take all those words and find the frequency of co-occurrence. And from that, those outputs, remember those 1 and 0s, essentially modifies it a little bit, but creates these types of values that we see. So it's using an AI system to then use as an input to another AI system. So it's not done by hand, it's learned. Yeah.
Thank you.
Any other questions about embeddings? Yeah, in the back.
Yeah.
I'm curious about the system you use to visualize the data set.
Oh, it's not mine. It's made by Google. I wish I could say it was mine, though. Yeah, it's if you Google Word2Vec.
Word2Vec, okay.
Word2Vec, yeah, it's made by Google and you could find it. Yeah, it's a great thing for your classes to pull that up and show students, what's happening under the hood a little bit.
Thank you.
So then transformers. So now we have these numeric inputs, right? So what do we do with them? We then use this type of transformer architecture to figure out what words in a large section of text are the most important. And the details for this are a little bit complicated and not fully worth going into, but relies on a system called masked self-attention, where it's taking a whole sequence of text, finding the information that's most significant, and then able to, excuse me a second. It's then able to take those types of the information of the most relevant things and generate new text. And the way that it generates new text is by figuring out the probability distribution across all those possible words. So we had the ways that they were related in the embedding space, right? But that doesn't really get us much. We then take a new model and we say, figure out, if you see this word next to this word, what's most likely to come after it? And we train it over and over and over. Okay, so now you have 2 words and here's a third. What happens if you had a 4th and a 5th and a 6th, right? And you keep going over and over and over and over. And that's what this type of architecture allows us to do, is to train a system to be able to not only recognize the important text, but then from that important text, figure out what's likely to come next. And that relies on the third piece here, which is how these models are trained. So the first piece, pre-training, takes large text data sets, which are stolen data sets, and gives it to a model and says, essentially, here's some sentence. We're going to mask, we're going to cut off and hide some words. We want you to predict what should be in that blank spot. And over time, it learns that and is able to then generate new text based on those probabilities. And it relies on fine-tuning, which is the next step, which is we have this model and it's imperfect. It has just gleaned what is available from all this text that it was provided, but it's not the best. It needs to be tailored for both human audiences, but then also tailored to be more accurate and more fluid in its language. And that happens using some smaller, more controlled data sets. And the third step is a very, very important one called reinforcement learning from human feedback. This idea is now that we have this fine-tuned model, it's almost perfect, but it's not fully where we as humans would say it's usable. Because an example might be, if I went on there and I said, was Hitler a good person? If you had an untrained model, it might just start saying stuff you really don't want it to say. So reinforcement learning aims to take an imperfect model like that, have it generate outputs, and then have those outputs rated by a human. And based on that human rating, it teaches the model what a good and a bad output looks like. Often this relies on some skilled workers. So maybe like OpenAI will hire engineers. Actually, someone in our research group did some reinforcement learning and for a company. And it would produce an output for like in technical language. And she would say, it's good or it's bad. Other times, reinforcement learning is done by third world, often African countries where they are outsourcing labor so that people sit at a computer and say good output, bad output. And unfortunately, that is still very prevalent in the industry. And there are some active lawsuits right now about the types of challenges that come up if you're dealing with models that are spewing this type of negative information all the time and you are hearing it all the time, and some of it can be quite bad. So all these steps are very important for large language model training and allow us to go from that embedding space to now being able to generate text. Any questions there before moving on? Yeah.
Why do you use the word embedding? Embedding seems to me that something that decides some other thing.
Yes.
Then, why wouldn't you use, for example, cluster that is also related to how words are clustered together and how they're in this meaningful space?
Yeah. Embedding has been used. So the question was, why do we use the word embedding versus something like clustering or some other term? Embedding has been the word that's used for quite some time to refer to the embedding space, which is this space of meaning that encodes the words. You might also use the word encoding as like a synonym type of thing. The reason clustering isn't often used is because what we might then do in the embedding space is cluster similar words. So if we said that we were clustering, then would we be clustering clusters, right? So the embedding is more to say we are taking language, words, embedding them into numbers, or encoding them into numbers, converting them into numbers. It's just, to my knowledge, that's the language that we've been using for some time. I'm not exactly sure who came up with it, though. Good question. I could look that up. Any others about LLMs? Okay. So, as I mentioned with training, a big goal here is to make sure that the model does what we want it to do. And this is a theme throughout, not just large language models, but AI more broadly. But the way that people have been studying how to do this type of verification, correctedness, is often talked about as model alignment. And now this is a very inflammatory word. It means a lot of things to a lot of different people, and some people have very strong feelings about alignment. This framework on the left is a large synthesis of different alignment research and created 4 different broad ideas here. So robustness. Here, can a model withstand an adversarial attack? Can it withstand when we give it some garbage input? The idea here is, can we make a model do what we want it to do even when we give it bad information, misleading information, all that sort of stuff? Is it resilient across scenarios? The second, controllability, subject to human oversight. Is it interpretable, which is a word meaning, do we know why it's making interpretability is the next one. Controllability is doing the things that we want it to do in the situations that we want it to do. So can it generate text in an application that we care about? Does it not generate text in applications we don't care about and don't want it to do? And that goes into interpretability, which is, do we understand why it made those decisions?
Can we peer under the hood, if you will, and figure out why it said one thing and not another thing? And that's a really big area right now, is trying to make these models more interpretable. The last one is ethicality. And this is typically where people get very interested in model alignment, because you might be able to create a model that is good across different scenarios, can handle an adversarial attack or a black swan attack. But when it comes to ethicality, morals, values, what does it really mean for a model to be aligned with human values? And that's the box on the right here. When we talk about values, I mean, this is a very simple idea, simple diagram here, but do we want a model to align with our values at an individual level? If I'm very comfortable talking about some things, should it be willing to talk about those with me? Or should it be say, no, we don't want it, like maybe at a cultural level, we've decided we don't want people to be talking about a specific topic. I'm not going to name one because I don't want to get myself into trouble. But can we make these types of cultural? Which is the idea that we could have a model that works across all these different cultures, all these different populations, and does what we want it to across all of them. And I don't know about you, but I think that they all present very different challenges, but extremely challenging challenges. If you're saying something is aligned at a cultural level, who are you talking to, right? Whose culture is it, right? If you're talking about a universal level, is there such thing as universal human values? Who knows? I don't know. So there's a lot of work in this space right now around model alignment, people taking different stances, companies taking different stances on how they have their models behave. But this is a very key idea, and something that as educators, we can talk to our students about, because we don't make those decisions about whether or not a model is going to output one thing or another thing. That's decided by a company that made the model. And often, if it's made by, let's say, a company in the United States, or a company in China, or a company in Brazil, if it's learning from all the text, like if it's learning from internet data collected in America, that message, the cultural messages that it understands from that is probably going to be quite different, right, than any information that it got from data collected in Brazil, let's say. So something to definitely consider when it comes to what correct means for these different models. Okay, so I think the poll it worked last time. The question here, based on all that background on AI, how it works, an LLM, in your opinion, is closest to a thinking machine, a very sophisticated autocomplete? Yeah? I think the... Oh, that's weird. I don't know why it didn't pop over to that screen. Other options, a database with search, and then the last option is magic. Yeah, it's okay. So far, a lot of sophisticated autocompletes. Database with search. No magic? It's a little bit of magic. It's pretty amazing that it's able to do what it's able to do. Okay, cool. Can you see it on that back screen now? This slide? No? Okay, I'll wait. Any questions while we wait for tech to teach us about tech? Yeah. Sure.
about the
Mhm.
things about the fine tuning,
Yeah.
especially in the using workers
Yeah.
in the third country.
Yeah.
And we are using these tools nowadays.
Yep.
And they are getting or stealing our data.
Yeah.
Please.
Yeah. So the first question was, when it comes to these tools when it comes to these models, they use often labor, low paid labor in developing countries. So could you talk more about that? If you Google Amazon Mechanical Turk, Turk, it's a service offered by Amazon that allows companies to buy worker hours. And that system has been used by many AI companies to hire labor to do this type of task. And as you can guess, it's quite a boring task. It's also not one that takes a significant education. And it's also not one that these companies are really willing to pay a lot of money for, because you're looking at a model output and saying, I like it or I don't like it. And as a consequence of that, often the people who are hired by Amazon Mechanical Turk or to do this type of labor, it's called crowd labor, ghost work, are some other terms. A lot of them don't have a sophisticated education. And also many don't have a lot of options in terms of employment and have to do this because it's a source of money, right? And we all have to make money. So it's a very touchy topic in the field. And there are obviously human rights concerns when it comes to using this type of labor for training like this. And as one example, in Kenya, there is an active lawsuit against OpenAI because workers are claiming they were traumatized by model outputs. So it's serious. It's a very serious concern. And as users of these technologies, we just kind of accept that it's blind to us, right? We don't think about this when we're using them, but yet without that type of labor, these tools wouldn't exist. So it's an important thing to think about in your own practices, about maybe the companies that you want to support, the practices that you want to support. And it's still something that's being figured out, definitely. And the second part of your question was about using these tools ethically. Could you repeat it one more time?
While we're using our AI tools, they are getting our data.
Yeah, the data, the scraping of data. And in the United States, I know in particular, so the question is, how do we handle the fact that all of these companies are taking data, stealing data from people? In the United States, this is a huge concern from a legal standpoint. There are many active lawsuits, both from newspapers, from independent artists, independent journalists, all sorts, universities, who are concerned that these companies took their data without asking at all. And as an example, at least for us as researchers, some of these big companies that publish research papers are now taking all those research papers that are hosted on their websites and making amazing new models, right? Look at this, we have all this research, all this new knowledge that all these amazing researchers produced for us, right? And look, we can just make a product and sell it to people, right? I wasn't asked about it. I don't know about you or any of you, but they didn't ask me if they could take my research for those types of models, but that's what they're doing anyway. And I think it's still to be seen what types of permissions are required, what types of data like authentication is required. And a lot of these cases are still being decided in court, and we're gonna have to figure out where they go. But it's a big question, it's a big challenge for the industry, because also what happens if all that information that creates these models, what if you can't use it anymore, right? What happens to the capability of them over time? So it's a double-sided sword. Yeah.
Is that screen good now?
Yeah.
Yeah, okay. Okay, so how can you work with large language models today? This is a really key point because on that pre-survey we sent out, thank you for completing it, we found that a lot of you are familiar with ChatGPT, a lot of you are familiar with Gemini, but there are other ways to access large language models than just those platforms. So you can see major models. So we have those commercial models, right? The ChatGPT, the Gemini, Claude. Some of those claim to be general purpose or multimodal because they can handle text, they can handle words, they can handle text, they can handle images. We also see some other models called like O3, O4, or DeepSeek R1. These ones are called reasoning models. Whether or not they're reasoning is a little bit, who knows? But the idea is that they take more time with your prompt, and they might also take your prompt and split it up into littler prompts and answer each one of those individually to show you that it's thinking through some steps. Some of those are proprietary and some of those are openly available. We also have some models that are really good at code performance, like those from Anthropic. But then there are also models that have been released to researchers, to the public, in a way that ChatGPT is not available. So if I want to use the GPT model, I really have to go to ChatGPT, or I have to use what's called an API, an application programming interface, to work with OpenAI's models. And I have to use their software to do that. I have to use their models. And I also have to pay OpenAI to use their models. Others, like Llama, which was released by Meta, Facebook, are what are called open weight models. And these ones you can actually download to your machine and run them on your machine. And you can use them as much as you'd like. The reason they're called open weights is because remember from the neural networks before how they were all those different arrows were connected? What you download when you download one of these types of models are all of those weights, all of those connections between the nodes in that architecture. And you then need a system on your machine to be able to run those different weights and to handle them. But this is a different type of system than those commercial ones because you don't have to pay. You also can switch them out very easily depending on your application. And you also can customize them a lot more. So an example that we've used is taking one of these models and actually tuning it on some of our data so that it creates an output that we like more for our use case. And we can only do that with models that we have this type of controllability over. There are also some models that are integrated with services, right? Gemini, as I said, this Qwen 3 model, this model is from Alibaba. And an important thing with the Qwen model is that it's Apache 2.0 license, which gives a lot of flexibility to developers who are using them. That's not the case with all these different models. Some of them have different permissions. And as researchers, as educators, that's something very important for us to consider is what are these permissions that we're standard. It's something everyone can understand, right? You know my time. A benchmark is a similar way that these companies are doing that type of performance checking. But there are some problems with benchmarks because they don't always mimic the real world all that well. So when you dive into what these different benchmarks are asking, they can be very specific problems. And some of them, like the GPQA, which is like graduate level questions. Supposedly, if a model can do well on these graduate level questions, then it's a graduate student or something. And I don't know about you, but my days are not always filled with just answering rote questions that a model is being asked. So when someone reports that, look, our model can do amazing on this benchmark, there's some more interpretation that has to happen because it's not just a direct relationship between the question and then maybe the world knowledge required to understand that question, or even what that question is like in real life, right? Our worlds are not just question after question after question after question. They are fluid, dynamic, immersive experiences. And benchmarks don't capture that all that well. In addition, these models have been trained on so much text, that a big concern now is that they've actually already seen many of the questions in popular benchmarks. So if you've already seen it, then you probably can generate the right answer to it, which means the benchmark doesn't do what you want it to do. Like if I was playing chess and I just had a computer telling me all the right moves, and I was like, oh, look, I'm an amazing chess player now. Like, am I really an amazing chess player, or did I just have the answers ahead of time? Additionally, we talked about this a little bit before. It might utilize ghost work, crowd work, data labor to create the right answers for these different benchmarks. And that's another big question, is not only are they used in training, but there are large data sets that are used for these different types of tests, because you take a large data set and you give it to a model and you say, how well does it answer the correct answers for that data set? Well, how do those correct answers get determined? Often by labor, low paid labor in other countries that are looking at, let's say, a picture of a banana and saying banana, and they write banana, and you do that all day. So another question when it comes to how ethical these different systems are. And the last point, professional knowledge, I touched on this, requires a knowledge of relationships, judgment, moral understanding. That's not being tested. This is just, here's a question, does it fill in the right answer? And I don't know, I think that matters quite a bit. So when we see something like GPT-4 passes a medical licensing exam, ask yourself really what that means. Is it a doctor now? Or did it just happen to know that this word was most likely to come after that specific question? And recall what's caused the last 2 AI winters, just as a little remember. And to talk about this in an engineering education context, this paper from 2025 looked at if ChatGPT could pass an undergraduate engineering